So it may be clear that if an x, y, and z satisfy this equation, it has to be on this plane. And if you remember from geometry, two planes that are not parallel intersect at a line. So we have two non-parallel planes intersect at a line, and then if you have a line that intersects with a plane, either it's on the plane, if it's on the plane, so if we have a plane like this, and so we have this line right here, if we have another plane, so this is the line I'm going to draw, either it can go straight through the plane and intersect at a point, or it can be on the plane like this, in which case there's a lot of points. All the points of the line satisfy it. Or it can be sort of parallel to the plane. So it could be like this. It could be equidistant from the plane at any point. Okay, so those are the three cases, similar to the idea that two lines either intersect at a point or they don't intersect anywhere. This is in two dimension. They don't intersect anywhere. So let me go back. Shh, please. In two dimensions, if they either intersect at a point like that, or they're parallel, or they are the same line. So that's the connection. Okay, so let's go into a system of equations. I'm going to do this, but I don't think I'm going to have time to solve it. So let's say we have quarters, dimes, and nickels, and someone says that the value of our coins, and we don't know how many quarters, dimes, and nickels we have, but the value is $1.60. That's the value of our collection. Move down a little bit. The value of our collection is $1.60. That's a terrible $1.60. We have a total number of coins. Total number of coins is equal to, let's say someone tells us that we have 10 coins and that the number of dimes plus the number of nickels is equal to the number of quarters. Okay, so forgive my penmanship. So, and they say, how many quarters, dimes, and nickels do we have? Well, we need to use this information right here to set up our system of equations. Let me switch to cyan here. Well, if it's equal to $1.60 and we have Q quarters, D dimes, and N nickels, we know that 25 times the number of quarters plus 10 times the number of dimes plus 5 cents, right, times the number of nickels, that's just values right here, is better equal to 160 cents. Right, so that's just this constraint right here. And what about the total number of coins being 10? Well, that's just saying that Q, let's do that one right here, Q plus D plus N is equal to, that's right, 10. And then we know the number of dimes plus the number of nickels equals the number of quarters. Let's do that one in green. So we know that Q plus N equals D. So how are we going to take these 3 bits of information and solve? It's going to be a matter of substitution, elimination, substitution, elimination, elimination and resubstitution of answers, so that if we solved for the number of quarters and dimes, we would be able to come up with nickels. That's right there. Resubstitution, so going back, substitution, and all the other things that we also have to check our solution. So that's how we'd come up with the answer right here. So I'm going to leave this right now as it is right here. But I'll give one small hint, and I'll give that in blue. If the quarters plus nickels equals dimes, we have quarters and nickels right here. Quarters plus nickels we could substitute in and solve for dimes. That's all I have to say about this one. And oh, this is a so how is this what would this look like in 3 dimensions? So x, y, and z. But in this case, we have, what do we have? Quarters, dimes, and nickels. We have quarters, dimes, and nickels. And each one of these equations is a different plane. One plane, another plane intersecting like this, and then another plane like this intersecting at what? Exactly. So we have, let me go backwards. We have another plane intersecting at what? That's right, a line. And then we have another plane like this intersecting at, bam, a point. Okay, I hope that was clear. If not, I don't know.